Solving equations using logarithms. So let's have a look at this equation. 2 to the power of x equals 7. So you could apply the log definition here and change it around, but that's not necessarily going to help you solve it if your calculator doesn't have base 2, because if you change it around, we're going to get x equals log 7 base 2. Another way to do it is to log both sides of the equation with whatever base you want. So we're going to log the left-hand side with base 10, and we're going to log the right-hand side with base 10 as well. Because in an equation, whatever you do to one side, if you do it to the other side, the equation holds true. Now we can use our log law knowledge. When we have a power, we can bring it to the front. So we get x times log 2 base 10 equals log 7 base 10. And we can divide both sides by log 2 base 10. They're going to cancel out. We're going to get x equals log 7 base 10 over log 2 base 10. And if you put that in your calculator, you'll get 2.8 to 1 decimal place. Let's have a look at another one. 1000 times 0.93 to the power of x equals 100. So we're going to apply something similar here, but we just need to get this term on its own first. So we're going to divide both sides by 1000. Thousands will cancel. We're left with 0.93 to the power of x equals 0.1. Now we can go ahead and log both sides with whatever base we want, and we're going to choose 10. So when we log the left-hand side, we'll get log of 0.93 to the power of x with base 10 equals log of 0.1 with base 10. Using our log law knowledge, we can bring that power down to the front. So we get log of 0.93 base 10 times x equals log 0.1 base 10. Divide both sides by log 0.93 base 10. So they're going to cancel out on the left-hand side. And we're left with x equals log 0.1 base 10 over log 0.93 base 10. That we can use our calculator for. And we'll get x equals 31.7 to 1 decimal place. What about log of x base 3 equals 2? So we could apply the log definition here as well, but let's look at another way to do it. If we have an unknown in a log, we actually want to make the left-hand side and right-hand side powers with a particular base. And the base we want to pick is whatever the base of the log is. So we're going to pick a base of 3 and raise each side, the left-hand side being the power on the left base and the right-hand side being the power of the right-hand side. Because when we do this, we have a base with the log of the same base, which is going to cancel each other out, and we're left with x equals 3 squared, so x equals 9. Just bear in mind, you could have applied the log definition straight away. If you did that, you would have got x as the subject, 3 becomes the base, and the subject becomes the new power, so you could have got it straight away like that as well. But it's a good trick to know. What if we have log of x plus 1 in a bracket, base 4 equals 3. Let's try the trick we just learnt. So since our base of the log is 4, we want that to be the base on both sides. We take the left-hand side being the power of this side, the log of x plus 1 base 4, and the right-hand side being the power on the the new right-hand side with this base. The 4 and the log base 4 cancel out, and we're just left with x plus 1 equals 4 cubed, which is 64, minus 1 from both sides, we get x equals 63.